Swayam Prabha. Digital India. Educated India.
In today's class, we are going to study about the grinding fluids, which is indirectly the cutting fluids in terms of single point cutting tool, and the same thing can be used as a grinding fluids also. Okay, and what are the additives that one can add and its adverse effects? Normally, the cutting fluids are the fluids that normally uses for reducing the temperature and improving the tribological conditions and other things. During this course of time, the basic problem comes is emissions. So, how the emissions are coming and what are its problems and consequences. So, in broad spectrum, we will see the grinding fluids, what are the additives, why we have to add these additives, then we see what are the consequences of these additives. Okay. So, overview, we will see the grinding fluid, which is nothing but the cutting fluids, then the cutting fluids and its functions, types of cutting fluids, cutting fluid properties, additives and ecological effects, as well as its adverse effects or consequences of these grinding fluids in the grinding process. Need of cutting fluids in the grinding, it has a great importance. This is the workpiece, as you might have seen similar setup in the previous classes. So, if you are not going to use what is happening here, you see that machining region completely there is a fire type of spark is coming. So, because of this spark, the temperature of the grinding wheel goes up, but since it is a non-conducting, so there won't be problem for the grinding wheel, but the problem is the burning of the workpiece. So, the surface integrity, which means surface morphology plus surface metallurgy, the surface metallurgy will drastically deteriorate. For that purpose, in order to protect the workpiece, we should use the cutting fluid, so that the cooling as well as lubrication action will take place and you can enormously reduce the sparking. So, if you see here the difference between this grinding zone and this particular zone, okay, so the workpiece will be well protected in this condition. This is another workpiece where the wet grinding is going on, here the dry grinding is going on. This is the dry condition, this is the wet condition. Okay. So, because of this dry and wet conditions, you can improve your workpiece in a great way in terms of metallurgical changes. Okay. For that purpose, we need to go for the cutting fluids or the grinding fluids. So, whenever you want to look at the tribological aspects in the grinding process or metal cutting process, you come across with Strieback curves, and normally this is, there are three regions. Anyhow, this particular thing I will explain whenever I am going to explain you the tribological conditions or the tribology of grinding and other things if time permits. Otherwise, just a glimpse I am going to give you here is this is the boundary lubrication, where metal to metal or grinding wheel to the workpiece, okay, will be contact. Assume that this is my workpiece and the grinding wheel both are in contact. This is called surface to surface contact. In other conditions, if surface to surface contact is there, in between there is a nano layer of cutting fluid. Even though you have metal to metal or ceramic to metal contact, you will have very minute layer of cutting fluid or the grinding fluid is there, that is called mixed lubrication. Then the third one is hydrodynamic lubrication. Normally, hydrodynamic lubrication you don't want from the point of grinding. Normally, from the grinding, this is the best suiting. Grinding, you want this one. Here what you will get is a wet grinding, and here you will just get the dry grinding. Okay, which we don't want is a hydrodynamic boundary lubrication in terms of grinding process. If this is the case, what will happen? There is no contact between the grinding wheel as well as the workpiece. So, which we may not like, but hydrodynamic lubrication is the most important and well signified lubrication in terms of most of the tribological conditions like chip tool tribology or bearings, other things. This is the mostly used one or mostly important one. But for our condition, I strongly suggest you to go ahead with wet grinding. You have seen in the previous slide, in the dry grinding, it is just the spark is enormous, and in the wet grinding, so you can avoid by having a micro layer or a nano layer of cutting fluid. Okay. So, various grinding process where the cutting fluids are used to avoid the grinding temperatures is nothing but, you can see here the some of the grinding, cylindrical grinding is there. Then the lens polishing, you can see here the lenses are grinding here. So, if the temperature goes up, this is the what lens that we are wearing basically. This is the lens that they are fabricating here. Okay. If the temperature goes up, what will happen? It will damage the lens. So, you can see the cylindrical grinding where the cylindrical components are fabricated, at the same time tool and cutter grinder. Normally, if you see here, the grinding of a cutting tool is doing here. So, if the temperature goes up, what will happen? The tool material will metallurgically change, in turn the life of that cutting tool will drastically comes down. So, you need to use the cutting fluids in the grinding operation. The cutting fluids, this is what is happening here is grinding. If you can use the cutting fluids, what will happen? The cutting fluid will come here and occupy these locations, and it will reduce the friction as well as it cools down the temperature of the workpiece. Okay. So, there are two types of abrasions are there. One is a two body abrasion, another one is a three body abrasion. Normally, when you call it as a two body abrasion, assume that this particular abrasive particle is fixed and it don't have its own axis of rotation, because it is a bonded abrasive particle. It is a bonded abrasive particle which is binded by the binding material of the grinding wheel. So, as per the instructions of the grinding wheel, it has to work. So, that means that whatever the machining or the grinding taking place, it is dictated by the bond. It cannot rotate about its own axis. That is called two body abrasion. This is the body 1 and this is the body 2. That is why it is called a two body abrasion. For example, if you go for lapping process or if you go for some other processes, or assume that in a soft wheel, that means that the grade of a wheel is very soft. In that circumstances, the bonding is very poor and these particles will come out, and it also involved in the machining process. That means I have a workpiece, I have the grinding wheel where my particles are there. So, there are some other particles which are delaminated or debonded from this one, and this also involves here. So, that means that these particular 1 and 2, these are the abrasive particles. These abrasive particles have their own axis of rotation to decide the surface roughness and other things, apart from 3 and 4. Okay. Okay. These are all bonded. 1, 2 is unbonded, and the 3, 4, 5 are bonded abrasives. Whenever you have an axis of rotation about its own axis, then it is called three body abrasion. You can see the workpiece itself is one body, body 1. This is body 2. and this delaminated or debonded are body 3. It's called third body. Okay. So, this is called 3D abrasion. Hope you understand. If there is a two bodies are involved in abrasion process like grinding wheel and workpiece material, it is a two body abrasion. Along with this one, assume that some of the worn out particles are there. This also involved in this one, where these worn out particles had its own axis of rotation. That means that these are independent. Then it is a three body abrasion. Three bodies. One is a grinding wheel, another one is a workpiece material, and debonded abrasive particles. Three bodies are involved. That's why it is called a three body abrasion. Okay. This is about this one. So, cutting fluids and its functions. Basically, the cutting fluid's major function in this particular grinding process is lubrication, because the abrasion is the main mechanism of material removal. So, to counter it, one must need a lubricating property. The second one is followed by cooling property. Temperature generates. So, in order to remove that one, you need a cooling property. Reduces the force. Obviously, if it act as a lubricant and cooling, then it will reduces the forces and energy consumption that is required. Protects the machined surface from the environmental corrosion. Normally, there will be some of the anti-rusting agents will be used in the cutting fluids, which can improve, or by forming a passive layer on the surface, it will protect from the environment. The flushing away the chips. So, if there is any chips, or you have seen in the previous class that the loading is the biggest problem in the grinding process. Whenever you push the cutting fluid onto the grinding wheel, what will happen? There is a possibility that the wheel loading can be reduced, and debonding of this loaded material will occur and it can come out. In that way, chips can be flushed from the grinding wheel. So, depending on the type of machining operation, a coolant, lubricant or both can be used. Normally, in this condition, you have an abrasion effect, you have a temperature effect. That is why you need to go for both, that is called lubricating as well as cooling properties that you have to go. You can see here, this is the pure one that is purchased. Whenever you mix with the water, normally it will come as a milky white color of the cutting fluid. The cutting fluid, normally if we want to classify, there are two varieties of cutting fluids. One you can classify based on lubricating properties, another one is cooling property. Based on these two properties, you can decide which type of cutting fluid you want. If I want dominating cooling properties, I can go for water based cutting fluids, and if I want only the lubricating properties, then I can go for the mineral oils. Okay. So, these are the two extremes, or I can go for mineral oil with additives. What are these additives? I will explain you in this particular slide only after some time. So, if at all I want both, as I explained in the previous slide, we require cooling property as well as the lubricating property. For that purpose, what you have to do is you have to make the emulsions. Emulsions means just you have to mix the mineral oils with the water so that you can make emulsion. But emulsion as such cannot work mostly. For that purpose, always people will go for some of the additives, basically that is called emulsions with additives. This is the region where you can go ahead and you can use it. What are the additives? The first and foremost additive is biocides, because it can prevent the formation of fungal, bacterial in the cutting fluid, because the people uses the cutting fluid some few months. Okay. In that circumstances, water is there enormously. Normally, cutting fluids are made up of 1 liter of mineral oil is to 10 liters of water. So, in that circumstances, water is a dominating fluid. this water, if you are keeping for months, what will happen? Fungus, and you are keeping at a static level. For that purpose, this may generate or this may attack by the bacteria, fungus and other things. For that purpose, you need to have biocides, rust and inhibitors. If you are going to use water, what will happen? The final product that is coming out may be having rust, because the water will react, especially iron based work pieces. So, you need to have the rust or corrosion inhibitors, anti-wear additives. You need to have low shear strength materials. Whenever it comes to in contact with the two mating surfaces, it should shear easily. Extreme pressure additives, or the additives that you will use, so that even though at extreme pressure, it should form a layer, so that proper tribological conditions can be maintained. Okay. Cutting fluid types, normally water based, soluble oils, straight oils, mixed oils, chemical additives, chemical compounds and solid lubricants. Many more varieties are there. Nowadays people are talking about eco-friendly cutting fluids and other cutting fluids. Okay. So, normally the mechanisms or the methods of application of these cutting fluids, there are standard methods. One is flood cooling. Flood cooling you might have seen in the workshops, where you will use a small nozzle and just you by virtue of gravity it will come, or you use a small pump so that you can pump it. Okay. So, the biggest problem here is the cutting fluid consumption is around 500 ml per minute. Okay. It's a huge amount of cutting fluid. That is why the cutting fluid cost are approximately 17% of the product cost. So, another one is mist application, where you can mix the cutting fluid along with the compressed air, and you can mix in a two ways. One is internally you can mix, or externally you can mix, then you just push towards the machining region or the grinding region. So, high pressure additive systems you can use. Here there is no requirement of air, but you send high pressure cutting fluid into the grinding region. So, this is some other in a single point cutting tool or a multi point cutting tool like a milling cutter and other things. The fourth one also refers, that is you can make a internal holes in a cutting tool, but it may not be possible in grinding. Okay. Another one which you can use is a multiple nozzle system in a milling process, or this is another, since the milling and these are also comes under the multi point cutting tool processes, this is also explained. Okay. So, if you want more details about this particular course or cutting fluids, you can refer to one of my courses, is Introduction to Machining and Machining Fluids, which I have previously taught on MOOCs course. Okay. Special considerations: machines need to be washed after the fluids have been used, because if you do not wash, then it will be a problem. Okay. Cutting fluids may undergo chemical changes, because whenever you are using the first time, the chemical composition may be okay. Whenever it comes to the high temperature region, what will happen? There will be a chemical cracking will takes place. If you are reusing again and again, the chemical cracking takes again and again. So, the cutting fluid will undergo a drastic changes. Cutting fluids containing sulfur should not be used for the nickel based alloys, and chlorine should not be used with the titanium, because it is chemically reactive. Cutting fluids are harmful. Normally interrupted cutting operations, it is because the pressures or the forces of the cutting or the machining will come suddenly, so sudden jerk will come. For that purpose, you should be very careful whenever you are using the interrupted and curly chips and other things. So, you should be very cautious about these type of things. Properties: it should possess good lubricating properties. Obviously, lubricating, it should be non-corrosive, because if it is corrosive, then what will happen? Your lathe bed, other things will be rusted. Natural, so that not react chemically. It should not very easily flammable, it should be non-flammable. and it should be stable as well as high heat conductivity. If it has high heat conductivity, what will happen? The temperature generating on the workpiece because of the grinding action can be taken out. So, harmless to the screen, but because whenever the chemically cracked cutting fluids or the grinding fluids because of the high velocity of grinding wheel may sometimes splash onto the operator. So, this operator normally operates with the hand. In that circumstances, if it is fall on the hands or other parts of the body, it should not corrosive or it should not create any harmful to the operator. Okay, most important thing is whenever particular person want to sell the product, he has to sell the product at minimal price. When he can sell minimal price, if the production cost is less, so he can sell at the competitive price in the market. That is why the cutting fluids all should be economic. So, how to choose the choice of cutting fluid, on which basis the cutting fluid will be selected? So, the type of operating, which is normally in our condition, current condition, it is the grinding operation. So, rate of material removal, normally the material removal criteria in a grinding can be two ways. One can be material removal as well as another one is the finishing. So, if your condition is the material removal, the temperature will be very high. So, you should always go for the cooling type of. If you are going for the finishing type where the material removal is very less, for example, I am just telling, if the material removal is very less and I am talking about the good surface finish, that in that circumstances you should go for the lubricating oils. Okay. Material of the workpiece, if it is too hard, you should, the temperature will be very high. So, you should be optimally choose the cutting fluids or the grinding fluids. Material of the tool, that means whether it is a vitrified bond along with the silicon carbide, vitrified bond along with the alumina, or which type of things. Okay. Surface finish requirements, normally in a grinding you can go for machining, that is a material removal rate is the criteria, and another one is the finishing, final surface roughness is the criteria. This is what you have to check. The cost of the cutting fluid, always the final thing or the most important thing is it should be economic. So, cutting fluid additives, the cutting fluid additives will be like metal working fluids, normally it is common name. There are oil based and water based. So, if you see oil based or emulsions are the solutions where you will have extreme pressure additives, anti-wear additives, friction modifiers, emulsifiers, biocides, corrosion inhibitors, anti-foaming agents, anti-fogging agents, many are there, among which some are important, which we will see in the upcoming slides. The grinding fluid additives, the base is a mineral oils basically. Emulsifiers, normally sulfonates, soaps, synthetic tensides and all those things. Corrosion protection, sulfonates or soaps you can use. The pH regulators, alkalamines will be used, and wear protection, mineral oil, esters, sulfur and other compounds you can use. The biocides, formaldehyde donors normally used, and anti-foaming agents to prevent the foam in the machining region, so that the visibility will be very good and it will not interrupt by forming the foam. So, silicone oils or the waxes or calcium compounds will be used in this particular anti-foaming agents. So, we will come into the one of the most important thing, that is called emulsifiers. I said emulsions with additives. Okay, this is the mostly used. If at all I want to make an emulsion, I need emulsifiers. Emulsifiers are the substances which reduce the surface tension at the interface. The main function is if I have a oil, if I have a water, how to mix both. Okay. If I cannot mix, how to disperse properly. For that purpose, if I can reduce the interfacial tension, then I can disperse properly. The emulsifiers basically reduces the surface tension at the interface of the two normally immiscible phases, allowing them to mix. Okay. So, I can mix by adding a third one, that is called emulsifier. I have oil, mineral oil, I have water, I have mixed. it is not proper. In that circumstances, emulsifiers are used. Whenever you are getting a cutting fluid from the market, for example, the servo companies supply servo cut S. Whenever you mix into the water, automatically it mixes. You don't require any emulsifiers or something. Why? Because it is already inbuilt in it. Whenever you use it, it will mix properly. That is why you will always see white color milk type of thing. Emulsifiers belongs to general class of compounds that is called surface active agents or surfactants. Okay. Emulsifier molecules holding the water molecule and oil molecule. This is the oil molecule which is there, and it has a polar tail. This has a polar head and non-polar tail. Whenever, see, in a cutting fluid, what will happen? You are going to mix the oil with water. So, how do you want to mix? You will add a emulsifier. Emulsifier will have a polar head and a non-polar tail. Okay. The polar head will go and hold, or it will go and attach to the H2O molecule, that is a water molecule, and non-polar tail will go and attach to the oil molecule. In that circumstances, I have two things, one is a water, another one is oil. So, polar head will come and hold the water and non-polar will, so that it will mix properly. So, that is how the mechanism of emulsifier works between the two immiscible fluids of the cutting fluid. The working principle of emulsifiers reduces surface tension between two immiscible phases, so that you can mix it properly, and lipophilic tails are composed for the longer fatty acids. The polar head groups may consist of anionic or cationic groups, and the presence of both regions allow emulsifier to orient its phase interface. If it has a both polar and non-polar, what will happen? It can interact with the both immiscible fluids. Okay. Emulsifier stabilizes by the monomolecular interfacial films. Okay. So, there are many types of emulsifiers are there, monomolecular, some other molecular, many things are there. So, mostly what it will do is it will combine, or it will adhere to the two molecules of the cutting fluid, that is, one is a water, another one is a mineral oil, so that it can mix properly. The working of emulsifiers, you can see here without emulsifiers. If I am not going to use the emulsifiers, what will happen? The oil molecules are random sizes. Okay. There is no uniformity, and it can be a small one, it can be a big one. Okay. So, if you use the emulsifiers, what will happen? The proper mixing or proper dispersion will takes place properly. So, you do not find much difference between the molecules, but there is slight variation will be there, but you can reduce this size variation in the cutting fluids. So, there are many types of emulsions. One is oil in water emulsion, water in oil emulsion, multiple emulsions, that is oil in water in oil, water oil in water. Varieties are there, micro emulsions and all those things. If you can see here, water in oil emulsions, normally these blue ones are water, where oil is orange one. So, water molecules are there. In the oil in water, so this is the water, blue one is the water, always the sea look like a blue. So, you just remember like that, and this oil is suspended, immiscible fluids are suspended. Okay. Water in oil emulsions are the first ones. Oil is dispersion medium and water is a dispersion medium, greasy and not water washable, and used for externally preventive and other things. What I mean to say is, you have oil where you just dump the water. Okay. So, you have the emulsions. If you want to mix properly, just use the emulsifiers in these conditions. The second one is oil in water emulsions. Basically, you have the water where you just pour the oil. Okay. In this condition, water is dispersion medium as well as oil is a dispersion medium. non-greasy and easily removable from skin. Even though during grinding operation or machining operation, if the splashing occur, you can remove easily. Used externally provide cooling effect. Normally these are used externally for the cooling effect because your water content is more, so you will have the cooling effect. Water is more, so you will have always better cooling properties in this one. Okay, preferred for internal use as bitter taste of oil can be masked. Okay, oil in water, water in oil, these are the emulsions. Multiple emulsions. Multiple emulsions are, there are two varieties basically, oil in water in oil. Basically you have oil, then water and oil, and water in oil in water. So you have a water molecule, inside you have oil, and inside you have, and this is there inside the water. Okay, these are the two varieties. And the micro emulsions, whenever the size of these emulsions are goes into micron region, normally these are called as micro emulsions. But whenever these micro emulsions basically will be very small, in that's why it will be very good, it looks to the human eye, it is a very good clear emulsion, or clear stable and liquid mixtures of oil, water and surfactant, and frequently in the combination of these co-surfactants also used. In contrast to the ordinary emulsion, the micro emulsions form upon the simple mixing of the component and do not require high shear conditions. What I mean to say is, if my micro emulsions are used for mixing or for blending the two fluids in that circumstances, it can be easily formed. You need not to start with very high energy or something. Okay, for that purpose you can go for the micro emulsions, where you can make a good emulsions with the oil as well as water by mixing a micro emulsions with very less mixing efforts. The second one is extreme pressure additives. The extreme pressure additives work by reacting with a metal to form a compound that act as a protective layer on the surface. Okay. So, under these extreme pressure conditions, this compound layer wears away first. That means that these are some type of chemicals which reacts with the workpiece. Assume that the grinding process is going on. Whenever you are sending a extreme pressure additives, this will go and form a layer on the workpiece. Okay. So, even though the machining is taking place, what will happen here is, the first this layer goes off and it will protect the workpiece. This layer is removed, and what is happening here is, just you can see one layer is forming, and during the machining process it is going off. It is a nano layer for protecting the workpiece. Since the cutting fluid is continuously falling, the passive layer or the whatever the layer, that is extreme pressure additives layer, which is reacting to the workpiece, will form continuously, and this layer will be protecting for during the machining process. Okay. You can see here polar head and the non-polar tails are there. This is the workpiece material where the layer is formed here. Okay. So, even though the tribological conditions are severe, it will form continuously because the cutting fluid is falling continuously. So, it will protect at extreme pressures also, or extreme conditions of the grinding also. So, anti-foam additives, the foaming is not good basically, for the clear visibility will be loose, because the foam, as you see, assume that I have a water and just putting a surf or something, what will happen? I can see whenever you just mix it properly with the hand, whenever you are washing the clothes, what will happen? Foam will form. This foam will, you lose the visibility first, at the same time this foam, some of the bubbles may break, so which may cause some intermittent chemical actions and other things. That is why you don't want this foam to be in the machining conditions or as a part of the cutting fluids. If you see here, without anti-foam, there is a foam is forming which will interrupt the machining, may not be interrupting directly, but it will hamper the performance. In that circumstances, if you go for anti-foaming agents, so beautifully you can cover and you can do in a much better way. How these anti-foaming agents work? Okay, so what will happen? You have a foam inhibitor droplet and bubble risen from the surface. This is the bubble. This bubble anti-foam inhibitor droplet will come. This is the foam inhibitor which will come and hit the bubble form. Whenever it will hit the bubble and it breaks the bubble, so that it won't form the bubble. In this slide, you can clearly see the hydrophobic silica is the anti-foaming agent. What will happen? It will come and it will hit the bubbles. Whenever it will hit the bubbles will break, and there is similarly you have millions and millions of hydrophobic silica will be there. It will hit the whatever the bubbles that are generating. So the bubble generation or the foam generation will be drastically reduced. Some of the common anti-foam additives, you can see these are the polydimethyl siloxane, silicone oil and hydrophobic silica. These are the things. Whatever we are seeing in this present example is hydrophobic silica that is used in this condition. Okay. So this is one of the examples. Soaps and esters and fluorosilicones, these are the other things. Biocides are rancidity controllers. What will happen? Rancidity is caused by the bacteria and other microscopic organisms growing, eventually causing the bad odor from foam. That means that this is the grease. Normally cutting fluids, greases, these are all are the common cooling as well as lubricating agents. Since we are talking about the grinding process, lubricating should be a primary concern. For this, lubricating, the grease is one of the better lubricating medium. If you see here, there is a bacterial colony is formed. If it would have been mixed with the biocides, what will happen? Your lifespan of this particular grease or the lubricating medium would have enormously increased. Okay. The most of the cutting fluid contains the bactericides that control the growth of bacteria, make the fluid more resistant to rancidity. Rancidity means it is causing the bad odor. Normally whenever you see, if you smell it, you will get a very bad smell. Okay. The biocides defined as the active substances or the single ingredients which have an activity against the harmful organisms. That means that the bacteria, fungi, other organisms which will grow on this one will not grow whenever you add the bactericides, because it will kill the bactericides. Biocides are clear, colorless and odorless liquid, because rancidity, it means that it is a bad smell. If this also gives the bad smell, then there is no meaning. That is why it should be, whenever I want to measure a certain surface roughness or something, my master should be much smoother. Okay. That means that I do not want odor, means the primary material that I am using should not give any odor. That is what the most important thing of this particular point is concerned. Miscible with water and large and a range of polar solvents. Okay. Bactericides, normal examples are these things, and the fungicides, these are the two examples. You can see bactericide and fungicides, and biocides is nothing but it is a combination of both. You can kill the bacteria, you can kill the fungus and other microorganisms also. The next cutting fluid additive that we are going to study is anti-rusting additives. So in the anti-rusting additives, normally these anti-rusting additives are mostly used in water-based coolants, because as we have seen the lubrication as well as the cooling effects, whenever we want the good cooling effects, we have to go for the water. Assume that I am going to use the dominating water, very less cutting fluid. In that circumstances, the problem with ferrous based workpieces is the rusting. So to prevent that one, we have to use anti-rust additives. Okay. So water is the best cooling as well as economic coolant. Okay. So it is one of the best because the convective heat transfer coefficient or conductive heat transfer coefficient is high compared to the normal mineral oil based cutting fluids. That's why at the same time abundant water is there in the world. So it is economic as well as the best cooling component in the cutting fluid. So, but it causes the parts to rust, that is the components will be rusted. At the same time, rusted in the form of oxidized iron. Normally what will happen, the iron based workpieces will be rusted. Okay. So if I am going to use for machining of mild steel, okay, if I use the cutting fluid as a water, so it will rust because at high temperature when the water falls onto the surface, so there is a possibility after some time on that component rusting. Okay, there is a possibility to rust on that particular component after some time. Okay, so the chemical cutting fluids contain rust inhibitors. Normally whenever you are purchasing the chemical based cutting fluids, you will have the inbuilt rust inhibitors. Rust inhibitors act in two forms. One is the polar film formation and another one is passivating film formation. So what is this polar film as well as passivating film, that we will see here. Okay, the first is polar film. What do you mean by polar film? If you see the negatively charged long thin molecules attracted and firmly bound themselves to the metal. What will happen? These are the negatively charged long thin molecules which are adhered to the surface like this. These are there. So these are the negatively charged and molecules, long molecules which are adhered to the surface. This is the pink one is the surface. So on top of it, it is adhered. This is called the polar film. So if the polar film is formed, what will happen? If there is a water contact, then what will happen? The water, if at all the droplets are falling, what will happen? This will protect the negatively charged long thin molecules will protect from the direct contact of the metal, because this pink one is the metal, this is the metal. Okay, so it is protected by these thin structures. So in the other way, what is passivating film protection? So these are inhibitors combined chemically with a metal and form the non-porous protective coating that prevents the rusting. Okay, the other one is the passivating film. How it is going to form, just we will check. The inhibitors combine chemically with the metal and form a non-porous protective coating that prevents the rust. Okay, so here the most important thing that one has to observe is non-porous. That means that it is a purely a solid type of layer is forming. You can see this, these are the reacted ones which reacted and form on the surface. The pink one again is the surface, this is the surface, on top of it, it is forming. Okay, whenever it form, what will happen? Or the water try to come in contact with the workpiece, it cannot come because this passivating film will obstruct. So the rusting cannot take place. If at all rusting has to take place, there is no other option apart from removing the polar film that is formed on it or the passivating film that is formed on it. Otherwise, it will be very difficult for the water molecule to contact directly the iron based workpieces. That's how the anti-rusting additives will help by forming two ways, that is passivating film as well as polar film, to protect the main surface of the workpiece. There are other modes of corrosion inhibition. Then is barrier protection. These are also similar to the whatever we have seen till in the previous slide, and the cathodic protection, anodic passivation, active corrosion inhibition and self-healing. These are the other varieties, or some are the broad names for whatever we have seen in the previous slide. Okay, if you see the barrier protection normally what will happen here is, this is the metal substrate. I am talking about this particular thing. So what do you mean by barrier protection? So the barrier protection is on a metal substrate, you just put a coating which is a barrier coating. You can have this impermeable coating on top of it, so that whenever the water molecule come into picture, or whenever the water molecule come in contact with the metal substrate, it cannot. The other way around is hydrophobic or super hydrophobic coating prevents water from contacting the surface. So in the second barrier coating is hydrophobic or super hydrophobic coatings prevent water from the contacting surface. What will happen? Lotus leaf. If you see a lotus leaf, whenever the water droplet falls on it, what will happen? It simply crawls and falls off from the leaf. That is called hydrophobic or super hydrophobic surfaces. Hydrophobic. Some people may have the confusion about what is hydrophobic, hydrophilic, super hydrophilic and all those things. Just it is as simple as that one. What do you mean by? Just I will explain you the difference between hydrophobic and hydrophilic. Hydrophobic means you have phobia. Phobia means fearing. Assume that the lotus leaf is a hydrophobic surface. Whenever the droplet falls, it fears to contact the surface and it falls out. Or you will have phobia. Some of the people will have the phobia whenever you have to diagnose or something, whenever you will be sent into the CT scan, the cylindrical hollow cylinder will be there, just a patient will be sent. So some people will fear, that is called phobia. So immediately they will come out. Similarly, the water droplet also, whenever it falls, it has its own phobia to the surface, nature of the surface, that is called hydrophobic surface. Hydrophilic surface means it is happy to contact. Normally, whenever the water falls on hydrophilic surface, it will freely spread on the surface. That's okay. Philic means it will fill the surface. Phobic means it will remain as a droplet or approximately a droplet shape and falls off from the surface whenever it becomes inclination. Okay, that is the difference between hydrophobic and hydrophilic. So now coming to our hydrophobic and super hydrophobic coatings, what will happen here? This is the coatings. What will happen in this coating? If it is hydrophobic, the contact angle is more than 90 degrees. So it is a phobic surface. So if the water falls also, it cannot directly contact the workpiece surface. So it will directly go away from this particular surface itself. So it will go out. That is called barrier protection. You can have the bare coating or you can go for hydrophobic or super hydrophobic coatings. The second one is cathodic protection. So in the cathodic protection, basically you will have the metals such as zinc can act as a sacrificial anode. You will have a sacrificial anode before, whenever the water comes in contact with respect to zinc or the sacrificial material. So it will sacrifice itself before it will allow water to contact the workpiece surface. Okay. So this sacrificial layer, until unless the sacrificial layer is there, there is no water come in contact with the workpiece surface. There is no problem of rusting in this second case also. The third one is anodic passivation. Normally you might all know what is anodic passivation and all those things. A passivating layer that we have seen in the previous slide will form on a surface. So if there is a passivating layer which is non-porous, that means that it is a solid layer that we have seen in the previous slide, it won't allow the water to come in contact with the workpiece directly. In that way, the anodic passivation helps. Active corrosion inhibition. The active corrosion inhibition is a layered or double layered hydroxide loaded with the corrosion inhibitors. These are strongly binding ligands coordinate to the exposed metal surface, inhibiting the further corrosion. What will happen? These are the things which will align to the metal surface. Whenever the water falls on the surface, it won't allow the water to contact the original surface. That's how the active corrosion inhibition works. The self-healing, the self-healing in many ways you can see in a composites also self-healing composites are there, self-healing smart materials are there, many materials. Whenever there is a crack, these self-healing materials will grow into the crack so that it will wind up or it will cure the crack. So, similarly what will happen here is the breakdown of coating. Whenever normally what they will send is the sol gel coating. Here if you see in this particular picture, there is a sol gel coating repairing voids in the coating. What will happen whenever there is a breakdown of this sol gel coating, there is a capsules containing the sol gel precursors. These capsules will come and fall in this region. Okay. In that circumstances, the basic advantage is whenever the water droplet come in picture also, it won't have a direct contact. That is how you can protect the surface or the metal surface, or basically what I am talking about is the iron based surfaces from the corrosion. So, on all the cases, if you have seen, there will be a coating which helps, or there will be a sacrificial layer, or there will be a self healing layers. These are all will protect water droplet to come in direct contact with respect to the workpiece. Okay. This is how the corrosion inhibition will takes place, or these are the modes how the corrosion inhibition takes place. So, anti-rusting additives, if you see the anti-rusting additives, the composition, normally the anti-rust additive composition will have one salt, at least one of the aliphatic carboxylic acid having 6 to 20 carbon atoms per molecule, and at least one alkylamine. Okay. This slightly goes into the chemistry, okay. You have to slightly understand, and one salt of the at least one aromatic hydrocarboxylic acid having up to 20 carbon atoms per molecule, and at least one is alkylamine. This is another one. So, the weight ratio normally is 10:1. At the same time, at least one alkylamine in the free state should be available. You can see in the rusted state, this is the rusted one, where the machining has done without anti-rusting additives and with anti-rusting. Whenever you are going to use anti-rusting additive, so you can clearly see the difference between the 1 and 2. Okay. So, it is the beauty about the anti-rusting additives. That is why one has to mix the anti-rusting additives in the cutting fluid. If you are not going to mix, then your components, especially iron based components, will rust and you cannot sell your products into the market. Okay. So, if you become engineers in a certain in manufacturing industry, the main motive of this particular slide is you have to use the required amount. You should not use high or low, your required amount based on your application. Okay. So, some of the common anti-rusting additives we have seen in the previous slide: alkylamides of low melting point, alkylamine fatty ester compounds, monoethylenamine, isopropylenamine. These are the names of the anti-rusting additives that are used commonly in the cutting fluids or in other applications. Okay. Cutting fluid cycle, if you see, we have seen emulsifiers, which are nothing but the surface surfactant, which are nothing but the surfactants. We have seen anti-foaming agent, anti-rusting agent, many more additives, biocides and many more additives which we have seen. But this is a positive side of the cutting fluid we have seen, because from the performance of the quality of the component we have seen, but it has a negative effect. A rupee coin, assume that if you take a rupee coin, it has two sides. One may be a positive side. I am not saying about the rupee coin, I am just saying that you have one side positives and another side negatives. So, you also should accept, whenever you take these additives along with the mineral oil, the negatives also will come along with the positives. So, these negatives we will see some of the glimpse in this slide we will explain. I will explain you in this slide. Use of cutting fluid after machining, what will happen? The contaminated cutting fluid will come. So, contaminated cutting fluid means it is thermally cracked and it lost its original potential. I mean to say that the original potential is slightly decreased. Then there are multiple options. One is a cleaning. The cleaning is one thing that you can do before recycling, but it incur lot of cost and energy. Okay. The other alternative, you have to dump into the soil where it will lead to soil pollution. Otherwise, if you want to throw out into the water body like a river or a sea or a ocean, what will happen? It will lead to the soil pollution. These two, soil pollution as well as the water pollution, will cause in terms of health problems to the environmental destruction. So, you are destroying the soil surrounding your company, or at the same time you are destroying the water bodies surrounding your company. Okay. This is a negative effect from the soil point of view, from the water point of view. Better would have been to cleaning, even though some of the amount, but that will incur or that will increases the cost of your product, because this cost, whatever you are spending, a company spends the cost and energy in cleaning, you have to indirectly impose on the product that you are selling. So, people goes for this soil or water bodies dumping, okay, which is environmentally not a feasible solution. Otherwise, you can go for evaporations like mist cooling or minimum quantity lubrication type of things that people can go. So, this also causes some of the problems like lungs cancer, respiratory diseases and other things. Okay. We have seen the cutting fluids has its own positives. Anti-rusting additives will protect from the rusting, biocides will protect from the biological organisms growth like fungus, bacteria, other things. At the same time, these also have negative effects on the operator, that is a system where the operator is working on surroundings, which is nothing but the outside water bodies or soil bodies, or if you are evaporating something, then nearby the localities of the common people. These are all the negative effects. Okay. The more details about these cutting fluid emissions and other things we will see in the next class. So, the summary of this particular class is need of machining or the grinding fluids, introduction to cutting fluid and its functions we have seen, types of cutting fluids, cutting fluid properties, cutting fluid additives. At the same time, we have seen ecological aspects. It is just a glimpse of ecological aspects we have seen. Okay. So, the cutting fluid additives, what are the additives that are used and what are the positives of the additives, and we have seen what are the negatives of the cutting fluid additives in a glimpse. In the next class, what we will see is what are cutting fluids or grinding fluids and how this will affect the environment, operator, soil, water and other things. That we will see in the next class. I am very thankful for your kind attention and hopefully we will meet in the next class.